Okay, so now that you have down pretty good the questions with just two charges, Q1 and Q2, some distance apart, we need to spice it up a little. And so there's going to be a couple of other options that could happen. One thing that could happen is that FQ won't be the only force acting on the object. It might be that you have a charged particle here, some Q, and it's suspended maybe. Maybe it's suspended because there's a surface that's below it that's also charged. And so maybe this surface is charged negatively and this is positive, so it's going to experience a force of repulsion upward. And of course, gravity would be acting down. And if this charge is suspended, it means it's not moving, which means that FQ must be equal to FG. And so you could either find the mass of the particle or the charge of the particle depending on what you knew. Okay, so that's one option. Another option is that you might have more than just two charges, right? So this would be one of the Q's down here. Sorry. The other option is you might have more than two charges. You might have, and this is example 2 on the back of that sheet if you printed it out. Okay, so example 2 says there are 3 charges in a row. So there's a positive 4 microcoulombs. There's a positive 5 microcoulombs. And there's a positive 6 microcoulombs. I see a trend. And it says they're each 0.2 meters from the next. So this is 0.2 meters, and this is 0.2 meters. So if we label this one number 1, and this one number 2, and this one number 3, the question wants to know what's the net force on the central charge. So what's the net force on number 2? So the first thing you have to do is find out what is FQ12. What's the force that number 1 is putting on number 2? So you would do KQ1 Q2 over R squared. So it would be 9 times 10 to the 9th Newton meters squared per coulomb squared, times Q1 is 4 times 10 to the negative 6. Q2 is 5 times 10 to the negative 6. And the distance is 0.2 meters. And that'll be squared. So that's 4. So I think it should end up being 4.5, right? Because that cancels. Yeah, 4.5 newtons, I believe. Okay, and then you would, and it's positive, which means it's a force of repulsion. So then you would do FQ, it's asking for number 2, so 2, 3, right? What's the force that number 3 is putting on number 2? So you would do FQ, KQ, 2Q3 over R squared. So 9 times 10 to the 9th Newton meters squared per coulomb squared. 2 is 5 times 10 to the negative 6, and 3 is 6 times 10 to the negative 6, and that is still over 0.2 meters squared. Now, had I said, what's the net force on number 3, then my R would change, right? I would be doing 1, 3, and 2, 3, and so for 1, 3, my R would have been 0.4. But because we're doing both of them, we're finding the force on the 5 microcoulomb charge, they're both 0.2 meters apart. Okay? So that's 4, that's 1.5, so I think it should be 6.75 newtons. Okay, so once you get the two charges, now you have to look at what they are doing. I just need another colored pen. So what is number 1 doing to number 2? They both work out to be positive, and remember, positive is force of repulsion. So number 1 is pushing number 2 away. So FQ12 is going this way. And F3, number 3 is also pushing number 2 away. So FQ23 is going this way. So they're going in opposite directions, and that means you're going to need to subtract them. Right? So you don't just add them up because they both work out to be positive. The positive is telling us it's a force of repulsion, and a force of repulsion. We draw them in, and then once you draw them in, then you decide what do you do with them. They're going in opposite directions, then the net force on number 2 is going to be subtract 2.25 newtons and keep the direction of the larger. So in brackets we would say, because it didn't tell us right to left, we would say towards number 1. Because you could have drawn them up and down, but this would still be towards number 1, right? Okay, so that's example 2. Example 3 is the exciting one. So example 3 says you have 3 charges, but this time they're in the corners of a right angle triangle. Okay, so 1, 2, 3. So it says 3 charges of 5 microcoulombs, 2 microcoulombs, negative 2, excuse me, microcoulombs, and positive 3 microcoulombs are arranged in the corners of a right angle triangles with legs of 4 and 3 centimeters as shown. I hope you appreciate my as shown that is in there. So that one's 4, this one's 3, and this is a 3, 4, 5. If you don't know what that is, it just means you can find square 3, square 4, 9, 16 will give you, take the square root, will give you 5. It also means that this angle down here is 53.13, which you could find using sine and cosine, and 36.87. Okay? And so the question then wants to know what's the net force on the 3 microcoulomb charge. So you're going to need to do exactly what we did in example 2. You're going to need to find F13 and F23. So FQ13 will be KQ1 Q3 over R squared. So 9 times 10 to the 9th Newton meters squared per coulomb squared times 5 to the negative 6 coulombs times 3 to the negative 6 coulombs, and 5 centimeters has to be changed to meters, so 0.05 meters squared. And you get an FQ13 to be 54 newtons. Wasn't I nice picking out nice numbers like that? And then you do FQ23 because we're looking for the net force on 3. So you have to do what's the force that each individual guy is putting on 3 first. So Q2, Q3 over R squared. So 9 times 10 to the 9th Newton meters squared per coulomb squared times Q2 was negative 2 times 10 to the negative 6 coulombs. 3 was 3 times 10 to the negative 6 coulombs. And their squared is 3 centimeters, so 0.03 meters squared. Q23 ends up being negative 60 newtons. So now we have our 2 forces, but now we have to look at what are they doing to 3. Remember the negative means? Negative force is an attractive force is a negative thing. So here's my Q3, and it's attracting, right? The negative means, first one, let me do this one first. This guy is repelling, right? 2 positive charges gives us a positive force, it's repelling. So it's pushing it away, down like this. But this guy's attracting it. I just drew it down here so I wouldn't mess up but I can do it up there in another color in a second. Okay, so this is going to be the 60 newtons, and I drop the negative once I draw it in, and this one is going to be my 54 newtons. And if you want it on the diagram, right, so this one's pulling it this way, and this one's pushing it that way. And so we need to break this one up into its components, in the x direction and the y direction. And this 53.13 there they're opposite angles, so it'll also be 53.13 down here. Okay, so I'm just going to do it here because it'll be bigger. So this will be my x, This is 53.13. That's the adjacent side, so it should be 54.